Okay, we are going to be talking today about ohms, or actually, we're going to be talking today about series circuits. And a series circuit is literally, it is just a circuit with that is quite literally everything is just in one line. It's in one solid circle. So you're going to see something like a battery, and then you're going to have several different resistors kind of all working, but as you can tell, you've got just a single path here. So you're going to be given a voltage, and then you're going to be given a couple resistances. I'll call this resistance A, resistance B, and resistance C. Now, when you're doing this, there's a couple things that we're going to need to do. So the first thing is that I'm going to tell you to do is we're going to, one, we're going to find the total resistance. Step two, we're going to calculate the current through the circuit. And because literally we've got one path, that current, that flow of electrons is going to be the same for the entire circuit. But what's interesting is because I've got different resistances and the current's going to be the same, that means that the voltage, what we call the voltage drop for each of these resistors is going to be a little bit different. So then what we're going to be able to do is we can then calculate, oops, the voltage drop across the different resistors. So we've got, so we're only going to be using two different formulas here. We, our new formula is going to be for calculating our total resistance. And of course, that's just, our total resistance is basically the sum of my other resistances, like A, B, and C. If I had more, I would literally just add like RD, RE, RF, all of my different resistances. And we still need to use our Ohm's law, which is that voltage is equal to our current times resistance. So these are the two different formulas we're going to end up using. Let's go ahead and do an example here. Oh, before I do that, let's talk a brief moment about units. And one thing is, remember that if I've got, if our voltage is typically, our voltage is typically in volts. Oops, volts, not Volks. Thinking about my Volkswagen for some weird reason. Yeah, our voltage is typically in volts. Sometimes, if you're working in like industrial sorts of settings, you might end up with kilovolts, but most of the time you're dealing with volts here. But we're going to see a couple things with our resistances. With resistances, you could see things like ohms, kiloohms, actually that's an interesting question. I think it's kilo OHMS, kiloohms, or milliohms. And actually, yeah. And for the current, what you're usually going to see is amps. If you happen to have something in kiloohms, you're going to end up with milliamps. Or if you are dealing with milliohms, you'll end up with kiloamps. So essentially what happens here is in order to kind of meet up to 1, you have to multiply 1,000 by 1,000th to get to just a simple volt. Same thing here. If you had 1,000th for a resistance, you'd have to multiply by 1,000 amps in order to get just a volt. So these things kind of match up. You have to be a little bit cautious with your units, but and I hope that kind of makes some sense. So if you think about that, if I've got 1 volt would be equal to, if I have 1 kiloohm, that would be literally 1,000 ohms, and that would be times, oh, that would be R, and then say times my amps, and that would be, say, 1 milliamp, that would be 1,000th of an amp. And the same thing happens if I do it as 1,000th, if I do a milliohm times a kiloamp. Now, kiloamps are not something you really want to contemplate. This is not something that you're going to run into very often. But anyway, let's get on with some examples, shall we? And first off, let's talk about. Now let's do this example. I'm going to say we've got a series circuit here. And let's say that our voltage here is, I've got 36 volts, and I've got 2 for my resistor A, I've got 2 ohms. For my resistor B, I've got 1 ohm. And for my resistor C, I've got 3 ohms. So the first thing that we need to do is calculate our total. So that means our total resistance is, of course, in this case, it would be 2 ohms plus 1 ohm plus 3 ohms. So my total resistance is going to end up being 6 ohms. Okay, 2. Let's find the current. So with this, we know our voltage is equal to our current times our resistance. In this case, it's the total resistance. So what we're going to do here is we're going to say, oh, that's a 36 volts is equal to our current times our resistance of 6. And then from here, I can divide everything by 6. So it turns out that I will have a current of 6 amps. And now, let's see, we could figure out what what our voltage drop is across any of these. So here, we're going to find our voltage drop. So basically what's happening is if I've got, so let's do this for resistor A, shall we? And say, okay, for resistor A, I've got my voltage is going to be equal to current times my resistance. Oh, I know my current is 6. My resistor A was 2 ohms, which means my voltage drop is going to be 12. So across resistor A, it would be, my voltage drop would be 12 volts. Okay, what happens if I don't want to do that one? Okay, well, let's say I want to do resistor B. Okay, well, let's see. Resistor B, voltage is equal to my current times my resistance. So my voltage drop here, in this case, is going to be 6 times 1. So my voltage drop across B, which I'll put my little B subscript on here, would be 6 volts. Okay, well, what about resistor C? Okay, for resistor C, oh, for my voltage drop for C, that's going to be my current times the resistance C. So we'll have my voltage C is going to be 6 times that 3, and that's going to be, oh, this is going to end up being 18 volts. Now, I want you to notice something here. If I were to add these up, 12 plus 6 would be 18. 18 plus 18 would be my total voltage, which is 36. And that's a good way of checking if you want to do all three. All right, this is all I've got for you for right now, so I will catch you in the next video.